Hope you're all having a good time at ReactConf so far. Yeah. Great. My name's Vaughn, and I'm on the React core team at Facebook. And today I'm going to talk about some of the developer tooling work that our team's been doing for the past few months. Before we begin, I want to say that developer experience and user experience are both really important to our team. But today's talk is about developer tooling, so we're going to be focusing on developer experience for the next few minutes. Specifically, we're going to look at the work we've been doing to improve the following 3 areas: speeding up the process of writing components, streamlining the process of debugging and performance profiling applications, and making it easier to stay up to date with the latest React APIs and features. Our work on tooling isn't about adding new capabilities to React, but rather helping you do what you've always been doing faster. Let's take a closer look at each of these areas and what the team's been working on. First, let's talk about how we're speeding up the process of writing components. Those of you that follow React Twitter may have heard about a recent project called Fast Refresh. Let's take a look at a quick demo. For this demo, I'm going to edit an example React component and change a few things about it, like the text color, or the font size, or even the text itself. As I make these edits on the left, the React app on the right quickly refreshes to show the changes. This is all done by Fast Refresh. So let's start by talking about how a tool like Fast Refresh works at a high level. First, it's meant to work in a local development environment with a bundling tool like Webpack, Parcel, or React Native's Metro. These tools are responsible for combining multiple files or modules into a single file and running them through a compiler like Babel. In development mode, bundlers can also watch the file system for code changes and automatically restart the build process. When a file gets changed, the bundler reruns its plugins, which include tools like Babel and Fast Refresh. Fast Refresh processes the updated code, determines if it's a React component, and if so, decides how React should update the component based on the type of changes that were made. Once the change has been processed and compiled, the Fast Refresh runtime schedules an update with React, so the new code gets shown in the browser or native app. Some of you might be familiar with the term hot reloading. In a lot of ways, hot reloading is similar to Fast Refresh. Both automatically reload an app when code is changed. So why did we make a new thing? React Native, for example, has had the concept of hot reloading for a while now, but it had a few major limitations. Hot reloading didn't support function components, so no hook support. Hot reloading also didn't recover from syntax or runtime errors. For that matter, hot reloading wouldn't reliably reload after certain types of changes, which may have been because hot reloading was always a bolt-on user space solution that required patches and code transforms to work. So how is Fast Refresh different? To start, it's now built into React as a first-class feature, meaning that we're committed to supporting it with future updates. It's also built to support all React renderers, which includes React Native, React DOM, and anything else. And it supports function components with hooks, and component state is saved between reloads. So here we have a React component that uses the state hook to increment a counter when touched. If I edit the font weight, Fast Refresh re-renders the component without resetting its count state. And this is true for any type of edit I would make. Fast Refresh also recovers after syntax or runtime errors. So in this case, I'm going to intentionally add some errors to an example component and then fix them to show that Fast Refresh recovers afterwards without me having to do anything special. So how does Fast Refresh do all of this? If you're really curious, all the code is in GitHub, but I think it's worth highlighting a couple of the techniques used because they're really interesting. So hook support is probably the most exciting aspect of Fast Refresh, so let's talk about how it works conceptually. But first, some terminology. When I say update, I mean re-rendering a React component while preserving its state. And when I say remount, I mean unmounting the old component code and remounting the new version with new state. So when code changes, Fast Refresh has to decide whether it should update or remount the component. To help make this decision, Fast Refresh computes what it calls a component's signature. This signature is a string that describes which hooks the component uses and in which order. For example, a component that uses React's state and memo hook, like the one above, might have a signature string like this. Okay, so fast refresh computes a signature that describes which hooks are used. Why is this useful? Each time the component's code changes, fast refresh recomputes this signature. If the signature is the same, then it's safe to update the component. But if the signature is changed, then fast refresh knows it needs to remount and reset the component's state. For example, if we modified the component behind me to replace the state hook with a reducer hook, the signature will change. So fast refresh knows it needs to unmount and remount. This is good because hooks work differently, and trying to share state between them could cause them to break. Under the hood, React stores hook state in an array. Built-in hooks like useState are tracked in this array. Custom hooks aren't directly tracked because they have no state. They use the built-in hooks for this. Because of this, React itself doesn't even need to be aware of a custom hook. For example, here are two custom hooks, useFetch and useSubscription. They both use the built-in state and effect hooks to do something. These custom hooks would both look the same to React, but they shouldn't look the same to fast refresh because it's probably not safe to share state between them. To account for this, fast refresh includes custom hook names as part of the signature it creates. So for example, if we started with a component like this and modified it to return a span instead of a div, fast refresh would preserve the hook state when updating. But if we were to replace the custom fetch hook with a different one, fast refresh would see the change signature and would remount the new component with new state. So in other words, the signature helps prevent the state in our custom fetch hook from leaking into and breaking our subscription hook. Here's another interesting case. What should happen if you change what you're storing in a hook? So you may have noticed that fast refresh's signature includes the name of the variable the return value gets assigned to. That's because if you rename this variable, it implies that the way you're using the hook, what you're storing in it, has changed. Changing the variable name, then, will change the signature. For example, the component behind me uses the state hook to manage a value named isLoggedIn. If we were to change this code and rename the variable to isLoggedOut, fast refresh would see the change signature and would reset the state. Let's talk about what fast refresh won't do. It intentionally does not maintain the state of class components between reloads. We've learned that it's too hard to reliably hot reload classes without them ending up in an invalid state, so we always remount. And if a module exports both React components and non-React components, fast refresh will always remount the React components to avoid potential inconsistencies. Lastly, fast refresh may also run useEffect and useMemo callbacks more often than React otherwise would. In other words, they may be run even if their dependencies didn't change. It does this to ensure that a component and its internal state is always consistent. Generally, this shouldn't cause problems, but if you think you found one, please let us know on GitHub. At Facebook, we monitor internal usage of developer tools like fast refresh. The old hot reload mechanism was only used by about 15% of Facebook engineers because it was pretty unreliable. Within the first few weeks of rolling out fast refresh, we saw opt-in usage increase to over 50% of engineers. At which point, we enabled fast refresh as the default experience, and now almost 100% of Facebook engineers are using it. I'm personally really excited about fast refresh, and I imagine some of you may be wondering when you can start using it too. The good news for React Native developers is that it's already been released with version 61 and is enabled by default. It's the React Native manager there. React DOM support hasn't landed yet, but there's an active GitHub issue with a couple of contributors working on a Webpack integration that could be added to Create React App or other projects using Webpack. And there's an open pull request that adds support to the parcel bundler as well. So we hope support will land soon. Those of you who know me from Twitter know that I like to talk about a few things: making music, going running, my cat Gatsby, and the React developer tools. This year, we've invested a lot in DevTools to speed up the process of debugging and profiling applications. We started with a complete rewrite. Everyone here loves rewrites, right? But they're a serious commitment because the time spent rewriting old code is time not spent adding new features. So why did we choose to make this investment? The old DevTools had gotten pretty slow. The primary goal of a rewrite was to improve performance so that large apps, the ones that need DevTools the most, could actually run the extension. We also added support for several new React APIs, and the new architecture allowed us to make several user experience improvements as well. Working in an unfamiliar code base is challenging. We've made several changes to DevTools that I hope will help you more easily navigate unfamiliar projects. Let's look at these together. How do you get comfortable with a new project or code base? Getting a better sense of how the code is structured can help. One of the ways to do this in a React project is to look at what each component renders. In this example, maybe the app component renders the navigation component, and the navigation component renders everything else. But in order to know that, I would have to look at the source code for each of these components to see which elements they create. DevTools gives you a way to zoom in on a component and see what it renders. To zoom in, just double-click a component. Now we see only the elements rendered by that component. Double-click another one to zoom in farther. You can use the breadcrumbs up top to step between components, and then when you're done, click the X button to zoom back out to the full application. What do you do when a React component gets past an unexpected prop? Let's say I'm working on a website, and I notice that one of the navigation buttons has a misspelled label. The first thing I would do is look at DevTools. In this case, it shows that the misspelled label is coming in as a prop. So to fix this bug, I just need to find where the bad prop is coming from. I could start by looking at the component's parent and work my way up the tree until I find where the prop is defined. There's nothing wrong with this approach, but it's probably not the most efficient. For example, the menu component might not actually be the thing that rendered the button. It's fairly common to use wrapper elements like this for styling and layout purposes. In this example, to find and fix the bug, I would need to skip over the parent menu component and its parent navigation component as well, and look at the source code of the header component, because that's where the misspelled prop is actually defined. In some cases, this prop may come from even higher up in the application, so tracing through one parent at a time can be a slow process. DevTools makes this easier by showing a rendered by list in the right-hand pane. This list shows which components rendered the selected component and what rendered that component all the way up to the root of the application. It can be hard to explore a big application with a lot of components. To help with this, DevTools provides a way to filter the components so that you can hide the ones you're not interested in seeing, like host components. But we don't have to stop there. Components can be filtered by element type, display name, and source location. Controlling what's shown in the tree makes it a lot easier to find what you're looking for when debugging. If you ever need to go lower level than the DevTools interface, you can log an element to the browser's built-in console. There you can inspect its props and state, see the location of the component source code, and directly interact with the native elements it renders. We've also made it easier to tweak and test React components. One of the ways we've done this is by redesigning the interface for editing props and state. This editor now allows you to define new props and to change the type of props. Any JSON parsable value is supported. And I want to specifically thank an external contributor, Hristo, who worked on this feature. Another exciting feature of the new DevTools is that hooks now have the same level of support as props and state. This means that values can be edited, and nested arrays and objects can be expanded. Suspense is React's API for managing dependencies. This can mean anything from lazy loading code to fetching data to loading images. Suspense lets components wait for their dependencies before rendering, and it lets you create custom loading states to be shown while components are waiting. DevTools lets you quickly test these loading states with a new toggle. This makes it easier to design polished visual transitions for your app. DevTools can also help improve console warnings, making them easier to track down. In dev mode, React may log warnings to the console to let you know that something's wrong. These warnings include what we call a component stack string. It's kind of like a call stack, but for React components. It helps identify where in your code a particular error or warning is coming from. Component library maintainers have often requested a way to log their own warnings with the component stack. For example, without a component stack, the warning above could be pretty frustrating to track down. DevTools now provides an option to automatically append this stack to third-party warnings and errors. We hope this will improve the developer experience when using third-party component libraries. All right, let's switch gears for a few minutes and talk about changes made to the profiler. The profiler is a really helpful tool for optimizing React components. The old DevTools supported profiling, but only after it had connected with a renderer. Because of this, there was no way to profile the initial mount, which is one of the most performance-sensitive parts of an app. DevTools now has a reload and profile button, similar to the browser's built-in profiler. This button will automatically reload the connected React application and record profiling data for the app startup. Profiling data can also be exported and shared with other developers to enable better collaboration and debugging. To demonstrate this feature, we're going to export a profiling session from one DevTools window and import it into another. This is also a great way to share bugs with the team if you think you found one. When profiling an app, you might find yourself wondering, why did this component render? The profiler now helps answer this question by recording which props and state changed between renders. This feature is turned off by default because it adds a small amount of overhead to the profiler, but you can turn it on in preferences. Now let's record some example profiling data. And if you zoom in on specific components, the profiler would tell us which ones are newly mounted and which ones updated, in this case because props and hooks values changed. Thanks. The profiler also now displays a list of each time the selected component rendered during a profiling session, along with how long each render took. This list is a nice overview of the performance of a specific component. There are a couple things that we haven't talked about yet, and I couldn't think of a category for them, so let's just run through them quickly. One small but very useful recent addition that was added to DevTools is that it now remembers the previously selected element when you reload a page. I don't know if he's here, but Dan added this, so thanks to Dan for this. DevTools Search used to show a filtered version of the components tree, which I always found confusing. Search now shows results inline, just like the browser's find in-page search. Higher-order components have been a popular pattern in React for a while now. Higher-order component is a function that takes a component and returns a new component. Before hooks were introduced, higher-order components were one of the most popular ways of sharing behavior between components. DevTools now shows higher-order component names as special badges to make them easier to spot within the tree. DevTools will also now dynamically adjust indentation so that you never need to scroll horizontally. This was a bit of a controversial feature, but we hope it makes it easier for you to browse large trees. Okay, I know that was a lot to cover. So if anyone needs a refresher, visit react-devtools-tutorial.now.sh. This website is an interactive tutorial that teaches some of the DevTools features I just talked about. You can always reach out to me on Twitter with questions as well. Now on to something totally different. Let's talk about the work we've been doing to help everyone stay up to date with the latest React APIs and features. Codemods might be an unfamiliar concept to a lot of people. A codemod is basically a tool that helps refactor large-scale code bases. It's kind of like a much smarter find and replace that's run across your whole project. For example, let's say you wanted to update a JavaScript project to replace all of the var keywords with let where it's safe to do so. If your code base was small, like a single file, you could probably just scan the file and replace them manually. Maybe even use find and replace. What if your project was thousands of files? What if other people were contributing as well, meaning that you would have to deal with merge conflicts? What if your change got reverted for some reason and you had to rerun it again later? This is where codemods can help. Let's walk through the codemod process at a high level. It starts by reading JavaScript source code from a file. The source code is parsed and converted into an abstract syntax tree, or AST for short. An AST is a tree representation of the structure of a program. Each node in the tree corresponds to an element in the source code. The codemod itself is a small JavaScript program that modifies this tree. For example, a codemod could update this AST to replace all var declarations with let. Because a codemod is a script, it can do more complicated edits than find and replace could. And even something as seemingly straightforward as replacing var with let requires some logic to avoid making unsafe replacements. When the codemod's finished, it prints the modified AST back out as a JavaScript string. A small codemod like the one we just described can be run across thousands of files in a way that's fast and reproducible. So what kind of things are codemods good for? Renaming things, like variables, method calls, imports. They're good for reordering things, like sorting imports. And they're good for certain types of conversions, like updating a component to extend pure component instead of component if it satisfies certain criteria. They're not good for everything, though. For example, codemods aren't that useful for complex behavioral changes, like replacing component will receive props with get-derived state from props. They're not that great at fixing bugs either. A codemod wouldn't be good at making React application code safe for concurrent mode. Tasks like this usually require a more complex decision-making process. I'm mentioning codemods today, because we like when the React community is able to stay up to date with the latest releases. This way, everyone benefits from new API features, and there's less fragmentation for open source maintainers to manage. Codemods help with this. For example, the React team is responsible for updating Facebook's code base when we introduce breaking changes. This can mean updating tens of thousands of React components. While preparing for this talk, I looked back at a few of the APIs I've helped update since joining Facebook, and we couldn't have done it without codemods. Replacing React.PropTypes with the PropTypes package updated over 3,500 files. Renaming unsafe lifecycles updated almost 8,500 files. And replacing create class usage with ES6 classes updated 20,000 files. Don't clap. The reason we're talking about codemods now is that the React team maintains a curated set of helpful codemods on GitHub. We add new codemods to this repo when we introduce API changes that can be automated. We also test and run these codemods ourselves on Facebook source code to make sure they work as expected. Recently, we've made running these codemods as easy as npx react-codemod. For anyone who doesn't know, npx is an npm package runner that lets you run CLI tools hosted on the npm registry. So let's look at an example. We'll run one of the early React codemods. This one replaces create element function calls with JSX. First, we'll run the codemod command using npx. This will automatically download all of the npm packages required to run our codemod. Then it will prompt us about which parser it should use. And when the codemod finishes, our code will have been updated in place. Let's take a look at it. Let's do another. Here's a more recent codemod that some of you might be familiar with. It renames unsafe class component lifecycle methods. We're going to run this one on a real open source project using an older revision of React Virtualized. We'll use npx, just like before. This time, when it asks us which parser to use, we're going to choose flow. And a couple of seconds later, it's updated all of the locations where the old lifecycle methods were in use. Visit github.com/react.js/react-codemod to see other code mods the React team has published. And if you're interested in writing your own code mods, check out the bit.ly link behind me to see the var to let code mod example that we walked through earlier. I hope you've enjoyed this brief overview of the tooling improvements our team has been working on recently, and we also hope that you'll keep sharing your ideas and feedback with us. And that is my talk. If you have questions, you can find me on Twitter or come talk to me in the hallway. I'll post a link to the slideshow on Twitter, too, for anyone who's interested. And thank you all, and I hope you have a great second day of the conference.